my name's Clayton. I've been with BBD now for the past 24 years and been working in the cloud team as a senior solution architect currently. I've been in the cloud team now for the past 8 years and have a number of certifications behind me, from networking to security, as well as the AWS solution architect professional.
My name's Warren Gurney. I'm a senior solution architect. I work in the BBD cloud team. I've been an AWS solution architect for about 8 years now. I also hold the AWS network speciality as well as the security speciality. I think it comes down to having best practice patterns that we use as blueprints, and we align these with customer requirements. We accelerate deployments using reusable Terraform modules, and we use infrastructure as code pipelines with review processes to enforce structural control from the beginning of a project. This allows us to focus on designing and building unique requirements that a customer might have.
And to add to what Warren's saying, you also need to make sure that your documentation and your architectural diagrams are consistently updated and aligned with what's actually been deployed in the customer environments. So the first step is to assess what's currently being deployed. Often customers don't have any architectural diagrams. They have very little knowledge about what's running in their environments. So what we would do in that case is we would assign a senior solution architect. He would perform a comprehensive assessment of the environment, covering a number of different areas, from the landing zone architecture through to the account structure, the networking structure, security structure. We'd look at the compute and the data layer, all according to best practices, and then come up with a list of findings that we would then document, and then build an architecture diagram from that. Then also part of the assessment is to review the current deployment strategy and how the infrastructure is deployed and their repository structures. We would then evaluate all the findings and make recommendations on improving those particular areas, including cost optimization.
Just to add to that, we also find when taking over existing environments that hasn't been built to a best practice often requires significant remediation and rework. We prefer building out parallel infrastructure as code environment and then migrating services in a controlled manner. You need to implement a solid FinOps strategy upfront before deploying any infrastructure. This involves accurate cost estimates, as well as implementing cost categories and budget alerts, and then additionally cost anomaly alerts, and then give engineering teams visibility into these costs from day one.
Yeah, to add to that, we also recommend implementing AWS's cloud intelligence dashboards into our customer environments. Those we found provide deep insights into their cloud costs. Further to that, we've actually written a comprehensive article on AWS FinOps and the strategy that you need to follow, and that deep dives into everything Warren's just mentioned and a lot more. So it'd be good to have a look at that. So FinOps is actually a strategy really that you need to follow from the start. Often customers would end up trying to put something in place at a later stage. What we tend to do is we have those discussions up front with the customers in the workshops when we're busy architecting, and we would then come up with that FinOps strategy, document it, implement the tools necessary for the teams to follow while they're deploying. Then they can actually track their costs. Obviously, there's certain things that you can only do once your deployment has been running for a certain amount of time, because you need a trend to look at and implement cost savings plans and right sizing. But it's really a strategy similar to like a disaster recovery strategy, where it involves tools as well as processes that you need to follow. So cloud data transfer costs are often very difficult to quantify without having a decent monitoring solution in place. We either recommend a good third-party network monitoring tool, or one of the easier and cheaper options which we've made use of in a number of our customers is using the AWS Cloud Intelligence dashboards, specifically the foundational dashboard, which has a dashboard aimed at showing you your data transfer costs. You can see things like inter-AZ traffic, the traffic out to the internet, your transit gateway traffic, your direct connect charges, as well as S3 data transfer charges. We actually recently picked up an excessive cost on one of our customers, where the data transfer going out of S3 was over $2,000 on a particular S3 bucket. And that's something we would not have identified easily without using something like the Cloud Intelligence Dashboard. And that was then easily mitigated because we just installed a S3 gateway endpoint, which is free. AWS provides it to you for free, and there's no data charges.
Another key cost savings is when using large ECR Docker images, especially for dev environments, where they're pulling down a lot of images. You should rather use a VPC endpoint. This can save hundreds of dollars a month. And we've actually seen this on a couple of customers already.
There's obviously two options. What we always try to recommend is going with AWS native managed solutions, which a lot of them come with built-in licensing, for example. So those are obviously things that are easy to manage going forward because you don't have to worry about renewing it. It's built in, and it's built into the cost of the running cost of the instances. But then the customer may want to go for something like FortiGate, which Warren just mentioned, which is a third-party tool, software that's run inside of AWS. And they may already have their own licenses that they want to bring and make use of in AWS. So that's another option. Yes, so this is a tricky one because it involves trying to get an estimate out of the project teams for their resource expectations for the next year to 3 years. Often teams are reluctant to give you specific sizing, so you need to pick a compute option, savings option that makes sense for them and it gives you flexibility. So what we recommend is the compute savings option. That just gives you flexibility across instance families. So if you have a scaling activity that takes place, you can scale across instance families, you can scale across instance sizes, and you're still covered.
Just keep in mind as well that EC2 instance plans come with higher discounts and can be used for instances that never change. An example is in the shared network environment, we typically have an inspection VPC, and there could be, as we mentioned earlier, FortiGate firewalls in this environment. They're never going to change families, but you can scale them up. So in that aspect, you'll get better savings plans going with the EC2 instance. I think from the outgo, if there's going to be static instances, like for instance, firewalls, the instance sizing, you could at least get savings plans in that family, which allows you to scale up and down within that family. So you also want to make sure you don't overcommit though. And so, I guess the best is to trend it and see over 6 months, make sure after go live that everything's stable and then commit.
Teams don't fully understand exactly what their correct spec is up front. They're reluctant to give you that. So we normally try and identify as close as possible, but then we only find out later that once the load starts hitting that workload, that we need to either increase the size of the instances or scale out, set up scaling to accommodate that. And then obviously we don't want to overcommit on the instance savings plans. Maybe we actually overcommitted and we, in some cases, reduce the size of the instances. So the finance and engineering teams speak very different languages. So it's important to align the two through business-focused monitoring. For example, we recently built a highly available solution running in AWS on EKS. Now, an engineering team would fully understand the technical benefits of doing something like that, but the finance team will not fully appreciate the value that you get from that. So to bridge that gap, what we did is we worked closely with the application teams, and we built a Grafana dashboard which actually tracked business metrics, including things like number of successful transactions, the latency of the transactions, and these obviously against the agreed business KPIs. So now what this provided them with was a common view that both teams could easily understand. So we have built an AI agent into our cloud managed services portal that our internal cloud team uses, and that integrates into a number of applications, namely our Jira ticketing system where our incidents and obviously support tickets are logged, as well as our Confluence documentation, which we obviously keep up to date, and least privilege access into our customer AWS accounts. So what this now provides our support engineers with is an AI assistant that it can make use of and get deep dive into problems, look at resolutions, which you can get a lot faster than if it was going to go and investigate that himself. So it's had a big impact.
We also use AI extensively creating Terraform modules, as well as when we create customer infrastructure as code repos. The system helps us to do repetitive tasks and to actually verify before we even use the code. We also recently used AI to automate generating a Security Hub remediation plan document. This report used to take us 2-3 hours to go and put together. And now with the script that AI wrote for us, we can get that within 15 seconds. And then that gives us time now to go and focus at actually how we're going to remediate issues and focus more at that than trying to come up with a report. So in this example where we actually had Security Hub, the AWS dashboard gives you some ideas about how many findings it found, and the one example was there was over 1,000 findings. And by building the report, we could then go and correlate our report with what's in the dashboard and pick up any anomalies. So it did take a bit of work to get the script 100%, but now we're confident that amongst all the different standards and amongst all the different findings and guard duty and inspector, it all added up and we can validate that it's 100% accurate.
So we recently designed and delivered a new environment to one of our customers. This was to alleviate on-premise issues they were having with their infrastructure, as well as high latency they were experiencing. So the solution that we provided was a highly resilient solution in AWS across their compute, database, and networking layers, with connectivity using AWS Private Link to external AWS networks. So the solution obviously provided them with reduced operational overhead because we made use of these managed services wherever we could, as well as improved successful transaction times and lower latency day the AWS Private Links. So yeah, there was clear business value to the customer, and it was a good outcome at the end of the day.
In a separate engagement, we were involved with designing and building out a landing zone that required traffic inspection. The customer was very comfortable with FortiGate and FortiWeb WAFs, and their teams had already vast experience with these products. So it was a good fit, and we decided to go with FortiGate as the firewalling solution. We created purpose-built Terraform modules, and these were reusable, and it helped to easily deploy the environment. The customer then did full failover testing of the entire environment by failing certain firewalls and making sure that everything was highly available. And then they signed that off, and the project was successful and went live. For all our customer environments, we use services like AWS Control Tower, which implements governance and guardrails automatically across the whole organization. We also use managed security services to monitor security posture across the organization. This includes Security Hub, which then actually aggregates findings from other services like guard duty and inspector.
Yeah, to add to that, to ensure our customers adhere to a robust governance strategy, we'd work together with them. We would tailor a detailed disaster recovery plan that would meet their required RTO, RPOs that we would discuss with them in the workshops, and then provide obviously hands-on validation. After we've deployed everything, we would sit with them and actually simulate failures in AWS and do actual DR tests.
I think the thing that differentiates BBD from other AWS Premier partners is that we offer an end-to-end service. So not only will we go and build the actual landing zone with the network infrastructure and security posture, the FinOps we've mentioned already, we'd set that all up, but we can even take it a step further, and we have cloud platform teams that can deploy the actual platform, be it Kubernetes as an example. And then once that's built out, we've got our development teams that we do front end and back end and can actually go and deploy on top of that. So BBD offers a whole end-to-end solution.